Good morning, everybody, and welcome to week 2 of our 15-week course. Today is July 3rd, day before, it's going to sound weird to everybody, but it's the day before the 4th of July, and it's the 3rd. It's July 3rd. It's kind of weird how that worked out, how July 3rd worked out like right before the 4th. I don't know how, those things always seem to confuse me a little bit. I don't know why, but anyway, welcome. And let's get started. I think I've got everybody muted there. Let's get started. Maybe, there we go. Hey, I like to start every presentation off the same way, which is, of course, to say thank you. I really mean it sincerely, and it is always my goal every time I give any kind of presentation to make sure that the information that I give to you is at least as valuable as the time that you're giving to me. I know that with the holiday coming up this weekend, a lot of you have a lot of stuff going on, so I really do appreciate the opportunity to serve you in this way. Appreciate you being online.
Make it clean looking. So it's literally.
Make sure everybody's muted off. We have a full class this morning. It's awesome. Okay, let's get started. What we're going to talk about today is a little bit of filtration and kind of the mechanics of it. Now, I did want to tell you, when I put together the curriculum for this class, filtration is not actually talked about until chapter 1 in the water processing book. And what I discovered was most people, they end up reading that water treatment fundamentals book, which is just, it has so much chemistry in it. And I mean, it's really academic. It's really, and actually the one that was more valuable in terms of relevant stuff that was out there in the field is the water processing book. And so most of this class comes out of the water processing book. When I put together the curriculum for this, and I worked with Water Quality Association to put it together, the reason we put mechanics of filtration before we did any of the chemistry is because, for the most part, filtration is a mechanical process. It doesn't change any of the chemical makeup of the water. I mean, you do get a little bit of it, and we're going to talk about chemically inert medias as we go through this today. But for the most part, it's just basic, you know, it's just mechanical. There's no chemical change or anything. So it made sense to put filtration before we talk about chemistry. Next week, oh boy, that's when it gets fun. We start talking about chemistry and ions and all that good stuff. Boy, I bet you guys are looking forward to that. But today's pretty simple. All right. We're going to talk a little bit about turbidity, tank-type filters, different medias that are in the filters, cartridge filters. And let's start by talking about the filtration process. This is the most understood technology in water treatment. And actually, it's part of the hydrologic cycle. When you look at, you know, last week we talked about that cycle, the water cycle. The earth filters out quite a bit. I mean, when the water hits the ground and it seeps down through the soil, that's filtration. It's most understood. It's been used in water treatment for the longest throughout recorded history. And like I said, it's part of the hydrologic cycle. It involves the process of separating suspended matter from a liquid. So basically, you're just separating it, right? I mean, when you think of coffee filters or you know, a screen or anything that separates something from matter from a liquid, suspended matter from a liquid. Tank-type filters can filter down to about 10 microns. Micron, of course, is a unit of width. Human hair on average is usually anywhere from 70 to 100 microns, right in there. Usually 80 microns is what I've always heard, kind of a nice little average number there. Flocculants and coagulants can make this, can take it down to 1 micron. And what a flocculant does, besides give me great joy and pleasure just by saying the word flocculant, because I think it's a fun word to say. If you guys don't believe me, you should try it. It kind of, I don't know, it's just one of those, you ever depressed, just scream flocculant, and I bet you it will make you happy. It will bring joy to you. I don't know, it does to me. But anyway, flocculants and coagulants, what they do is they clump the sediment or the debris or the stuff, the suspended matter, they clump it into, into bigger chunks, bigger pieces so that it can be filtered out at more of it can be filtered out. So there are surface and screen, surface filtration, there's a couple different types of filtration that we look at. The first is screen filtration. This is a straining technique, and basically what this is like sifting flour. Okay, so like imagine this. If you were to go over to a neighbor's house and take like a utility knife or something and cut out a piece of screen out of one of their windows, okay, and then you went over and you got some rocks and sand and some dirt and a bunch of stuff, maybe from their flower garden or something, and you put it on top of that screen and started shaking it like crazy. The small sediment and dirt and stuff would fall out, it'd kind of sift out, sort of like sifting flour, but then you'd have big chunks of rocks and other debris and things that weren't small enough to get through the holes in that screen that you'd cut out. That's basically surface or screen filtration. Okay, now the thing with surface or screen filtration is it actually creates the second type of filter, which is a depth filter. So all the stuff that it has filtered out on the top there, you need to probably do this quickly before they see you. Also, just so, or when they're on vacation. This weekend might be a good idea. I bet you a lot of people are going on vacation. So this is the perfect timing for this class. You could actually try this over the weekend if you're not traveling. Of course, if you have a neighbor who's taking this class and you come home and one of your screens are cut out, then you might go ask them if they were just doing surface filtration and depth filtration experiment. And just so you know, that experiment is not sanctioned by the Water Quality Association or really Moti-Vitality. So, do that at your own risk. But just looking at you, Jen. Wow, you've gone through this class how many times, and you're just now realizing that? So basically, the depth filter is created on that screen filter. All the stuff that it has filtered out, all the top stuff there, that creates a depth filter. So it actually makes a better filter because you've got more layers of filtration. So all the bigger junk, like the rocks and all the debris and everything that the screen filter took out, that actually creates that layer, and that's a depth filter. Screen filter tends to clog easily because of it's filtering better, right? It's filtering all that stuff out. And then the depth filter, which we kind of talked about, but these are usually tanks filled with loose media. So here you have a couple different types. So the fine wire sieve, I guess you could use this or a strainer to do your screening filter experiment. I mean, it's not nearly as fun as the other way, but I guess it would work. And then you have your depth filter here. In the depth filter, you'll notice they put the fine sand, the coarse sand, you've got layers of different things on a filter media, of different size media and different types of media in that filter. So that's your depth filter. So because the water, it's going to go. Let me put on my pen here so you guys can, because one of the best parts of this class are my artwork. Ask anybody who's taken this class, they will tell you they're really excited about the artwork. Okay, so the water comes in and it goes down through like the fine sand and then the coarse sand and then up through the distributor tube, and that's a depth filter. It's a tank type filter. It's pretty much whatever what we use for the whole house filtration. Turbidity. Turbidity is not suspended matter in the water. It can be caused from suspended matter in the water, but turbidity is actually the measure of light that is scattered and absorbed by the water because of the suspended matter in the water. So turbidity is a measure of light. What is up with there we go. It is measured, and this is another fun word. This class today is filled with really fun words to say. Nephelometric turbidity units, or NTUs. Okay, so turbidity is measured in NTUs, or nephelometric turbidity units. You could say that too, nephelometric. I don't know why that word always makes me think of Sesame Street, and for some reason. But it's measured in nephelometric turbidity units, and it is the measure of light that is absorbed. Turbidity is a lack of clarity or brilliance in the water, and so you can actually have very turbid water without a lot of debris. So it could be, you could have a great deal of color, maybe even dark brown and still be clear, but without all that suspended matter. So turbidity, I mean, if you think about a cup of coffee is very turbid. It hopefully doesn't have coffee grounds in it, so a lot of debris and sediment and stuff like that, but it is very turbid. It's a very turbid fluid, and because it does not absorb the light, and that matters especially when you're looking at things like UV treatment and different water treatments that we'll talk about in the future. Suspended matter, if the turbidity is caused by suspended matter, it can be removed by mechanical filtration. A municipal plant may use coagulation agents like aluminum sulfate. You can use a multimedia depth filter for whole house treatment if you have any debris or sediment causing the turbidity there. Loose media filtration, well, one of the first things we have to determine when it comes to filtration is what we're trying to filter out. Obviously, every once in a while in this class, we go through one of these, like, duh moments. Like that's totally obvious. However, this is important. Water pressure and flow rate are crucial, and you will hear me say this over and over and over again. Water pressure and flow rate are crucial. They're absolutely critical when it comes to filtration. The number one cause of filter failure is going to be because of flow rates. The number one cause of filter failure is going to be because of flow rates. And you have to have a sustained flow rate. That's really important. So I was, we put in this big iron filter. We were using it for an irrigation system one time when I was, way back when I was in sales. And there was this subdivision with all these gigantic houses, and we were putting in iron filter, and we had to put several in parallel because the sprinkler heads had to have at least 12 to 14 gallons a minute. They were pop-up sprinkling heads. So we also had to make sure that these huge iron filters had enough backwashing rate, and because of their size, they by themselves needed it. I think it was 15 or 16 gallons a minute of sustained flow rate to backwash in order to lift the media beds. And so we went out and we used a 5-gallon bucket in order to check the sustained flow rate. And this is how you do this, basically. You need to see how many gallons a minute you're going to get. And I don't know if those of you going in the home have this or not, but I strongly recommend that a 5-gallon bucket be part of your tools that you keep in your trunk or in your vehicle, because it is that, and one of those little coil hoses is an extremely valuable tool, especially if you are working with filters. But basically in this house, we went out and we took our 5-gallon bucket and we hooked the hose up to it, and we started timing how many times we could fill that 5-gallon bucket in a minute. And so in this particular house, we were filling this thing over 3 times a minute. So, I mean, the water was just flowing out of that thing. And we did it because I had always learned to run the test for at least 5 minutes to make sure that you have that sustained flow rate. And as we were doing it, we got into minute 4 of that test, and the water just shut down, just shut off. It seems that, this is well water, it seems that all these other houses were drawing from the same aquifer. And so the well was running dry, so you had great pressure. The well was producing a ton of water pressure, and the pump was, and the water was just blowing out of there like crazy. But the well itself, with all the other houses in the subdivision that were irrigating and using this water, could not keep up with that demand. So there's a lot of ways to check. You want to use that 5-gallon bucket. You want to make sure that you have a sustained flow rate for a long period of time, and at least as long as the backwashing time of that filter. Otherwise, it will fail. Inadequate flow rate will cause filter failure. You may need to install these in parallel in order to get the higher, and that's important because like in these units that we had now, we were putting 3 of them in parallel. So, and I'll explain to you what parallel is here in a minute, but rather than putting in large, really large, gigantic filters, it may make sense to put in maybe 2 or 3 normal size filters, smaller filters, so that you don't need as much water pressure to lift that media bed. A typical domestic well will pump 5 to 7 gallons a minute. The jet pumps, those are the ones that plug directly into the wall and are up in the mechanical room, they will usually do a lot less, usually 2 to 4 gallons a minute. But a typical domestic, usually a submersible pump will pump usually 5 to 7 gallons a minute. I've seen them, you can get them that will pump more than that, depending on, if you're irrigating or using a lot of, if you need them for water pressure, if you need more pressure, then obviously there's pumps that will produce more than that. So here's the parallel install. Okay, so let me get my little drawing here. So the water comes into the house, basically, and it's coming through, and so it's like, okay, guys, we're going to go into the house, right? And then they come to this little split off here, and they go, oh, man, which way do we go? Tell you what, you guys go this way, and we'll go this way, and we'll meet somewhere in the middle. So these guys go up this way, and they're like, hey, all right, we're turning here, and then, woo, going through the filter. Hey, what happened to all the crap that we were carrying with us? And then they go over here, and then these guys go down here, and they're like, they're going through here, and woo, this is funny. What happened to all the crap we were carrying with us? And then they go around here, and then they meet back up in the middle, and they go, hey, what'd you guys do? Oh, man, we lost all the stuff we were taking with us. Yeah, we did too. It was the weirdest thing. We went through all the sand and filter media and everything. Oh, well, I guess we'll have to move forward without it. And then they move on into the house, right? So that's parallel duplex install. And the reason they would do that is because you can get a lot more water pressure going through both of these. That, by the way, I don't know for sure that that's what water says, but it's what happens in my head. So it's true. It's real to me, people. But you do that so that you can install, or so that you can get better flow rates, because the water, it splits off, basically, and you have 2 different paths. And since it's got to go through that filter, you don't have that reduction in flow rate that way. Now, when you put these in on a parallel install, you got to make sure that you stagger it. Like this is showing cartridge filters, so there's no head, no automatic backwashing or anything like that. And you can put, I've seen on cartridge filters, I've seen 5 or 6 of these things installed in parallel, so that they don't have a reduction in water pressure. If you're installing something that has the backwash, has a timer on it that is, an automatic backwashing valve, then you want to do it. You want to set them up to where they backwash at different times. So you want to stagger the backwashing times. This came right out of the book. This is just some filter medias and how much backwashing pressure you need. You're not going to need to memorize this chart or anything. The thing that is important, the biggest thing, is that you have to have proper backwashing flow rates. Tank type filters, most of them have downflow service. The thing with the tank type filter is it's the top few inches that do most of the filtering. It's just like that screen, right? As it's filtering stuff out, it actually creates more of a depth filter on top of that filter bed, on top of that layer. And that's called a filter cake, which sounds delicious, but is not, I don't think, something you'd want to eat. Although if you want to try, do so and get back with me. Let me know how that was. But on top of that filter bed, that's called a filter cake. It creates that layer up there. You can the same thing can happen, like if you're trying to filter out iron, then it can create that layer up there too. So tank type failure. Tank type failure is caused by inadequate backwash. It's caused by inadequate backwash. There's something called mud balls. Mud balls are when if it doesn't backwash itself properly, then you're going to get these big clumps of filter media and all the sediment and the stuff that it's filtered out of there. It all kind of glues together and clumps together into these big mud balls, and so it doesn't filter uniformly. Okay, that's caused from improper backwashing. So, or not backwashing often enough. I mean, the filter actually becomes a better filter. You really want this thing to backwash, especially, I mean, it's going to depend on how much water is being used, but a minimum of every 3 days. But the thing is, the filter actually, after it backwashes the first time and cleans most of the stuff out and kind of resets the bed and everything, and cleans all the mud balls out and keeps the mud balls from forming, then you've got the so right after it's done that, right after it's backwashed, then it actually is a decent filter, but the filter actually gets better as it forms the filter cake, right? Because now it's filtering stuff out just like that depth filter that builds up on your neighbor's screen. Eventually, what's going to happen is it's going to become too good of a filter, and so it's going to clog. It's going to slow down your pressure, and so like on that second day, if it's a 3-day backwashing cycle, day 1, it's an okay filter, it's going to work. Day 2, it's going to be an even better filter because it's got that filter cake on there that's filtering even better, but now you're starting to notice a reduction in water pressure. Day 3, if you don't clean this thing off, then you're going to have, if you don't start cleaning it out, then you're going to have a major reduction in water pressure, so you have to backwash it. If you're not backwashing often enough, then that filter cake and the mud balls will form, and the thing is going to, once that happens, if that happens, you can't really fix it by backwashing it. You got to replace the media. So it really needs to be backwashed. Filters, in order for filters to work, they have to be backwashed. The mud balls are the formation. They are affected and related to the media density and also to the water temperature. Remember we talked about last week the maximum density of waters at 39.2 degrees Fahrenheit. Water temperature does affect how much water you need to backwash. You know, the more viscous it is, the more pressure you need, the more flow rate you need on that. I'm sorry, the less viscous, the less dense it is. So the more pressure you need. You know, in our industry, it would be better for filters, and sometimes, in fact, you see this in a commercial setting, where short, squat tanks, so not the tall, not the standard tanks that we use for water softeners and our water conditioners and everything, but short, squat tanks would be better for filter because you would have a lot more of that top surface area, and you wouldn't need as much water pressure to lift that heavy, that deep bed of filter media. It's never going to happen, not in the residential industry anyway, because everything, it works better for storage and shipping when we can have standardized tanks. So that's why we have the same size tanks for filters as we do for our water conditioners and everything else. It's just easier to keep the tanks standardized. But it would be better, filters would work better if you had short squat tanks. There's a filter, the filter bed expansion. Basically you see here, so if you've got, this is a tank here, and when it's just sitting there, this is the top layer of that filter media. But when it's backwashing itself, what it does, it forces the water down through the distributor tube and up through that filter media, and what that does is it lifts that bed. So you'll see here, this is a bed expansion of 75%. Okay, so what that means is it's all this area, so the water is lifting this bed up, and it's cleaning all that stuff out of there, and it's allowing the debris and the stuff like that to go through to go into the drain. So it's washing that waste out of there. Your filtration media, there's a couple different types of media. Okay, I have a question here. Let's see. What would cause a neutralizer tank to become channeled? A neutralizer tank to become channeled would be, it could be that you're not changing the, well, it could be that it's not backwashing often enough. I mean, that's, you know, or not having enough backwashing pressure. I mean, that's kind of what happens with mud balls is it forms channeling. And by the way, what channeling is, for those of you who may not know, that's a great question, Aaron. So let me go through here. Okay, so what channeling is, so if this is the inside of the, and by the way, Aaron, you asked that question privately. Wanted to, unless you, and now I kind of blew it, unless you only want me to see the question, can you, when you guys have a question, can you put everyone on there, because we do record the comments, also the chats, and that helps those people reviewing the courses later as they're going through. So, but let me show you what channeling is. Okay, so if this is the distributor tube, and you got all the media in here. Okay, so here's your distributor tube right here, right? And you have all the media in there. What channeling does, it almost forms like these ant hills. Okay, so what you'll get is water that comes down. This is pretty good with just a touchpad mouse, touch mouse pad, isn't it? So what you'll have, right, is water will come down through here, and it will form these little ant hill paths through the media. So what, almost like I said, you know, if you ever look at the little ant hills, the inside, the underground, so the water will just flow right through these paths, and it won't really be filtered. Okay, that is caused from inadequate backwashing. That's what's going to happen when you form those mud balls. When you form, so the water's just going to go right through there. So with a neutralizing filter, that's calcite, which is a filtration media, and in fact, that's we're going to talk about calcite here in a second. But calcite's a sacrificial media too, which means that it slowly dissolves itself. So the pieces of calcite filter media actually get smaller and smaller and smaller because it's sacrificing itself to the water in order to neutralize. And so that is going to contribute to a more dense media bed. So you got to have proper backwashing. Calcite media, if we go back and look, I think it was listed on our chart here. Let's go all the way back right there. Oops. I think calcite was listed. Yeah, calcite, you got to have a minimum of 5.3 gallons a minute for the backwashing rate, and these are the flow rates that you'll normally get out of it. Now that's just a standard filter, the standard tank filter. You can get that more. You can increase that by getting a bigger tank. But remember, bigger tank, more media in it, the more backwashing flow rate you need. So I suspect that that's what's causing your channeling. Chemically inert media, the word inert means stable. It's not doing anything. It's not moving around. It's not changing. Okay, that's inert. And we'll see inert again in the future when we talk about chemistry. But chemically inert media means that it's just simply filtration. It's used for sediment and turbidity filtration. Let me get rid of my little drawing here. It's used simply for sediment and turbidity filtration only. So it's just going to take out, you know, it's just going to matter. They're multimedia products like silica sand, anthracite coal products, pumicite or aluminum silicate that's sold as something we call filter ag or filter AG, garnet sand. Then you have the multifunctional media, and multifunctional media works as a filter, but it's also chemically reactive, so it actually makes a chemical change to the water, and that's an example of that would be calcite, like we just talked about with Aaron. Calcite is used, and we are going to talk more about calcite in the future, particularly when we talk about pH. It works well as a filter, but it also is sacrificial. It also changes the water or the solution chemically as it's filtering. Granular activated carbon, to some extent, is also a chemical. It's a chemical or multifunctional media. It does work as a filter, but it also changes the solution or the stuff in the water chemically at times. So manganese green sand is another one. It has oxygen on it, and it helps oxidize the stuff that it's filtering out. Activated alumina, magnesia, or something we call Corasex. You're not going to need to memorize the different types of filtration media. This is a lot of just practical stuff here. So the filtration media, sand is the most widely used, and you may see that again somewhere. Okay, sand is absolutely the most widely used filter media out there, and that's because it's low cost and it lasts a long time. It's not a great filter, though. Sand is not a phenomenal filter. If you look at sand under a microscope, the sides of it are pretty smooth. So in terms of a filter media, it's not the best out there, but it is the most widely used. Anthracite, this comes from crushed anthracite coal, it's used for swimming pool filters. Activated carbon is very, very porous. After you guys get your CWS-1 course, there's a whole advanced, CWS advanced course, which I have a preparation course, webinar course for as well, on filtration. And you will learn in that course everything you ever wanted to know and more about carbon and how it's made and what it does and all the crevices inside of it and everything. It's pretty cool. Carbon is great for taste and odor problems as well. So this is just, again, right out of the book. It's a chart that talks about the different medias and what they're used for. This is kind of a cool chart. I actually have referred to this in the past for different things. So this came right out of the book. So this is your typical multi-layer filter showing a stratified bed of media. Also a picture right out of the book, but this is a typical, just a typical multimedia filter. Okay, so again, we showed this a little bit earlier, but what you have here are, you've got the lighter stuff and the heavier stuff down on the bottom. So the lighter stuff's on top, the heavier stuff's down on the bottom. And that helps it when it backwashes. It helps that media settle back down the way it's supposed to be. Okay, so it will usually stay in that order. So you've got your anthracite coal on top, your sand, and then your garnet. And this area down here is a gravel bed, and that helps distribute the water. So as the raw water comes in and it goes down through the filter media, it goes down through the lighter stuff first, then a little heavier, then the heavier stuff goes down through the gravel bed up through the distributor tube. But that gravel bed's good for when it goes into backwash and you force that water back down through. That gravel bed helps distribute that backflow water, okay, so that it can lift that bed up. What do you use? What filter media do you use? Well, it's dependent on the region and the water characteristics and the hydrologic conditions. If flow rate is 10 gallons a minute or higher, pretty much any media can be used. So if you've got really good flow rate, then you're not really limited in a residential situation on which media you can use. If the flow rate is 4.5 to 7 gallons a minute, then you can use usually granular activated carbon, calcite, although depends on how big the calcite tank is, because the bigger the tank, the more pressure you need. And pumicite, anthracite, and a lot of the systems out there are multi-layered, so they'll use a combination of these filters. They usually put carbon on the top because it's lighter. Sometimes you will see, and I put this here, carbon on top of resin, you will see people do this on top of a water softener. So they'll have a water softener with resin in it, and then they'll put a layer of carbon right on the top. Now, I've got a couple clients who do this regularly for city water, and they're totally okay with it. I myself, and this is a personal preference, this is not a WQA thing, but it's just my experience and from talking to a lot of people out in the field and seeing what works, I'm not a big fan of that. And that's because the carbon is going to fail way before the resin does. It's going to exhaust itself way before the resin does, and it's going to mix with that resin bed. And that means you're going to have to, when you have maintenance on it, you need to take more chlorine out. That means you have to replace the entire media bed, and, you know, all of it, resin and carbon and everything. So I really am a strong proponent of separate tanks, of separate media tanks. So a filter tank like with carbon in it, and then a separate softening tank, unless you have a conditioner that has that compartmentalizes it. So there's a couple units out there that have like the compartments inside of the tank, and so you can change one media separately from the other media. So that will work as well, but that's pretty common practice to do that, to put the carbon on top of the resin of the filter. Granular activated carbon, speaking of which, does a ton of stuff. It is the most versatile of all of the medias out there. It'll take out some suspended matter, some precipitated iron. It will adsorb chlorine. Now, that's not a typo. It's not absorb. It's adsorb, and we will talk about that more when we talk about adsorption and absorption. But it will adsorb chlorine. Taste and odors will take out. Pesticides, synthetic organic chemicals. Because it does so much stuff, it doesn't last as long. But the thing with carbon is it will always do some good. Carbon on a water line, on a water system, will never hurt it. It will always do some good. Calcite works great for sediment. It polishes the water up, and when there's dissolved iron in the water, it actually acts as a catalyst to remove a portion of the total iron. And that's the thing. Basically, the iron kind of attaches itself to the calcium and allows it to be filtered out more. So, or through ion exchange, it actually allows it to be ion exchanged out easier. So if you have heavy iron in the water, especially if you have low pH water, then the calcite filter will actually raise the pH, and then it will bind up with that iron and allow that iron. Some of it will be filtered out by the calcite. Some of it will be ion exchanged out if you have a softener after it, but the calcite actually makes the water softener work better. It makes it take the iron. It helps it take that iron out of the water. And like I said, it neutralizes low pH water. It's sacrificial, and we already talked about this a little bit ago, where because it dissolves. That's what happens with sacrificial media. So it's basically doing what, and we're going to talk about this when we talk about ion exchange and water hardness on week 4 and 5. But actually, it's week 5 and 6, I think, that we talk about that. But you're going to, it acts just like, calcite acts just like the calcium magnesium that's in the ground. When the rainwater hits it and dissolves it, then you basically you're adding hardness to the water with the calcite filter. Kumacite is used for sediment filtration. It's less dense than sand, so it requires lower backwashing flows, and it's very durable and porous. Anthracite is used for swimming pools. It comes in different sizes, so it can be layered. It's more expensive than sand, but it's less dense, again, so you have less flow rates required to backwash. It's kind of cool. All right, so if you have just a sediment and sand filter, like if you have a lot of debris or sediment and your well's leaching a lot of stuff in there, there's a couple different types of sand filters that you can use, but they should always be installed before the pressure tank, and that's because if you've got a lot of debris, a lot of chunks, a lot of that stuff coming in, that's going to build up inside that well pressure tank. So this is one example of how it works. Okay, let me move these boxes out of the way. Okay, so the water comes in and goes. So you have these compartments, right? So the water is going to come in and it's going to force it up through this filter, but you've got this screen filter right here. So this is almost like a reverse gravity filter. But so you've got this screen right there, and so the water comes in with all the debris and the sediment and the sand and everything, and it's like, hey guys, let's go on into the house together. And so the water goes up through there, and sometimes it will stand right here and laugh at the sediment, like ha 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 ha, you can't make it through, and and so then the sand and debris and sediment, it kind of soaks away and settles down here to the bottom, and then every once in a while, to make matters worse for this poor sand and sediment, you have the owner of the house will come in they'll open up this blow-off valve down here, and it'll go whoosh and wash out all that extra debris and sediment. So, and then the water goes on into the house. You know, water can be so mean sometimes, so cruel. But anyway, that's how it works. And like I said, it needs to be purged. And I don't know if you guys noticed, but I thought that was a darn good purging blow-off valve impression. It went like whoosh. I thought it was pretty good. I mean, it was even for myself, I felt like I was being purged. It was, I don't know if you guys felt that. It's like you looked around and said, oh no, there's a leak somewhere. But anyway, the thing is, you're often treating the system when you're using a system like this, and what that means is often treating the symptom. Okay, so it's sort of like if you had a leaky roof, then and you put a bucket under the leak instead of actually replacing the shingles on the roof. That's kind of what happens if you have a lot of debris or a lot of sediment. You probably have a well problem if you're introducing that much sand into your water. But if it's just a little bit of debris, then a system like this, a filter like this, will work pretty well. And then there's another guy. This guy is the cyclone filter, the hydrocyclone, and this is also a sand filter. It works kind of the same, or it's for the same reason. You have a little bit of sand and sediment, but the water comes in on this one, and it goes through, and it's centrifugal force, and it goes wee, 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 right, and it spins around, and because it's spinning, it kind of goes down, and because it's spinning around, the sediment gathers along the sides here, and it eventually comes down to the bottom. Now these are usually, they're installed sort of like a cartridge filter. They're not going to be this big whole house. I mean, they're a whole house thing, but they're going to be not as big as the big tank ones. So the sand settles down here, and so once a day or every so often you have to do this. So you have this little valve here. This is your sand release, and same thing. You don't even turn the water off. Okay, because you want that water pressure to come through and kind of. So you open this valve up, and it goes, like that, and the water blows out of there. That was a horrible impression, by the way. I don't know why that one sounded like I was in my throat or something. But you get the idea. So the water flows through there, and then goes up through the house. Same thing. You should install this before the pressure tank for the same reason. It also needs to be purged more often, and you're often treating a symptom. This cartridge filters are probably one of the most common that we see out there. We run across these quite a bit. They're just sediment filters a lot of times. Before you put them on before a water softener, or you can use them for lots of different reasons. Sometimes there's point of use and point of entry, and these can filter out smaller stuff than the tank type filters, and you get a lot more versatility on what type of media you can put in them. So you can put a little deionizing filter in, for example. But you got to change them periodically. You got to get rid of them. Usually they're just disposable too. It's got a little bit of filter media in there, and they're not backwashing. So when the filter's clogged, you got to change it. There's two ratings that we look at, and this is kind of important to know. And just even on the practical. In a practical sense, when you're talking to a customer, if you see on the side of a filter, if you see nominal rating, that means that it's going to take out 85% of what it says it's going to take out, so or at least 85%. So let's say you have a 20 micron filter, nominally rated 20 micron filter. That means that it's going to take out at least 85% of 20 micron stuff or larger. Okay. If you have an absolute rating, that means it's going to take out 99.9% of the stuff in the water. So if you've got a 20 micron absolute rated filter, then you can be pretty sure that it's going to take out 20 micron stuff or larger. Most of the sediment filters, the cartridge filters that we put on the whole house are nominal rated. You start to get into the absolute rating filters when you're looking at things like your pure filters or your Britas or your, the kind of filters that you would put on, possibly a reverse osmosis post filter will have an absolute rating, particularly if it's a, VOC filter or a carbon block. But you can look at those look to see whether they are absolute rated or nominally rated. Cartridge type filtration advantages. They're simple inline plumbing. There's no backwash or wastewater to accommodate them. They're easy to service. There's a greater versatility, lower initial investment, higher service flow rates, and less space required. The disadvantages, there's a higher operating cost in the long term because people have to change them more often and there's more maintenance. They tend to clog faster. You have to service them more often. Okay, this is just a chart, and you'll see this chart again in the future, but we are, when we're talking about filtration, we're over in this spectrum. This is just the chart that shows the microns. So anything 1 micron or larger is your particle filtration. Okay, when you start getting smaller than that, you're getting into different levels of like microfiltration, ultrafiltration, nanofiltration, and finally reverse osmosis. But you'll see here, like the human hair, this is where it's at. Visible to the spectrum, visible to the human eye, right in here. And that's still, so it just kind of shows you the ranges that you have for in the micron levels. Cartridge elements, the sediment and chlorine, that chart, by the way, is in the book. I actually always carried that with me into the home, just in case you needed to explain that to the customer too. So, but you can get that chart in the book. It's also all over. There's different versions of it all over the internet. So, cartridge elements. You've got your sediment and your chlorine filters. These are usually pleated impregnated cellulose. They're made out of a pleated impregnated cellulose or pleated synthetic fabric. And then there's string wound filters as well, and then bonded filters. And I have a picture here in a second where I'll show these to you. And then there's a powdered activated carbon and impregnated cellulose. I don't know why, does the word impregnated always make you think of the movie Aliens? For whatever reason it does me, I don't know why. And then granular activated carbon, so, and then there's block carbon too. So here's just a couple of these. Okay, so your string wound, they just wind the string all the way around that, and the tighter the wind, the better the filtration. This is your pleated filter, and the reason they do this so you have a lot more surface area on there. This is one of the common filters out there. Here's your resin bonded. So this feels like almost like fiberglass, but they put these lines in there again to increase surface area. So you have more surface area. That's what those lines are for. So better filtration. Here's your spun polypropylene, and then your carbon pleated. Now you will find these kinds of filters here. You'll find these at a store where, hang on, I might have to sneeze here. Sorry, that would be a little odd. Actually, it went away, so that's good. You'll find these like at the hardware store, the real cheap ones, and a lot of times the real cheap ones will just have this really thin layer of carbon on it, over the top of a piece of cardboard, and in no time at all, especially if you have too much water pressure flowing through that filter, it'll blow that filter right out and not even do anything. It'll blow right past it. I don't know if you've ever changed one of these in the cheaper filters, and it's just like almost disintegrated. There are some better quality carbon pleated filters out there, but it's usually just a thin layer of carbon around, you know, on a center component, and so that it's not going to do a whole lot. Now there are the filters out there where they'll take almost the entire thing, they fill it up with carbon. You can tell, sometimes you can shake it and hear them. That's what you tend to find a little bit on the RO filter, so you're running that carbon through. If you think, I've seen it actually in miniature fish tank filters too. You see that sometimes. So that's different than the coated, than a carbon pleated or a carbon coated filter. You've got the GAC filters, or they call them RFCs too, the radial flow carbon that runs right through that carbon. And that, everybody, is filtration. Any questions? Any questions that come up? Anything at all? Next week we are going to delve into the wonderful world of chemistry, which is always super exciting. If there are no questions this week, then please, everybody, have a very safe and happy holiday. Some of you taking a long weekend, you know, it's kind of nice. But please be safe, and I will talk to you next week. I will be around, so if anybody has any questions, you're more than welcome to give me a call. My phone's always available, and also by email. And I will talk to everybody next week. Thanks, everybody.